Hi and welcome back. In this video on understanding the results, we are going to look at bias, underfitting, variance, overfitting, and bias variance trade-off. A model is said to have a high bias when it does not have enough flexibility to learn from the data. A high bias problem occurs if the model is not enough complex. A high bias problem can occur in simple models like linear regression or logistic regression with very few features. Let's take this example. Here, we have two curves, this one and this one. Our task is to use a line and separate these two out. If we use a straight line, we'll get a fit like this, which is not a good fit. So this type of situation is called underfitting or high bias. A model is said to have high variance when it is too specific to the learning data. A high variance problem occurs if the model is not able to generalize to the actual scenario. A high variance problem can occur in complex models like support vector machines with lots of features or a complex kernel function. A neural network with many layers or lots of features is also another example where high variance problem can occur. If you look at this diagram over here, the new line is trying to fit the graph so well that it is not able to generalize after a certain point, and it is trying to capture each of these points exactly. One of the ways to detect high bias or high variance is through cross-validation. As you keep increasing the model complexity, the training error keeps going down, but at some point the validation error will start to increase. This is the optimal point where you have both low variance and low bias. A rule of thumb is that if the model is having high bias, it is good to increase the model complexity. And if model is having high variance, we can reduce model complexity or add in more data or use regularization, which we will see in the next video. In the next video, we'll look at ways to improve the model in improving the models. So I'll see you in the next video. Thank you.